I'm Adolph Oliver, and this is our lesson on translating words into expressions. To be able to use the power of algebra, you've got to take everyday situations and convert them to algebraic equations so we can use all the algebraic methods to solve them. Expressions, we recall, are one-sided, and of course, equations, which we can solve, are two-sided. How you can make an equation is simply connecting two expressions to each other on either side of the equal sign. So when we talk about translating words into expressions, what we're really doing is practicing translating half of an equation, and we'll of course put this all together in our next lesson. But first thing we have to do is take a look at common words that are used to indicate the basic math operations. The list we're going to look at here is by no means all the possible words that can be used, but these are some of the more common ones. For instance, for addition, you won't see plus too often, or added to. More likely something by increased by, which means we're adding something, increasing it. More than, well, we've got to add something to make something more. And the mathematical term for adding things, sum, you've probably heard before. Anytime we say some things, we mean that we want to add them together. Well, next up, subtraction. Subtraction, you might hear someone say minus or subtracted from. You know exactly what's going on then. But less than, meaning we're making something smaller, which means we have to subtract it to do that. Decrease by, also making it smaller, and the only way you can do that is by subtracting. But then there's also the mathematical term for subtraction, and that's difference. Now, difference is special. Subtraction is something that we have to watch out for. Addition, you can add numbers in any order, and it doesn't make any difference. You'll get the same answer. But subtraction, order is very important. We'll talk about this more when we discuss the commutative and associative properties in a coming lesson. But you always have to know what number is being subtracted, and it has to go behind the minus sign. So all of the words that we have here, except for difference, you have to make sure you know what's being subtracted, and it goes behind the minus sign no matter where it is in the original sentence or information you have. But difference is special. This is a historic thing in mathematics. Whenever somebody uses the word difference, then that's the only time you can assume that the words are in correct left and right order. The guy on the left is in front of the minus sign, the guy to the right is to the right of the minus sign. In all other cases, whatever the words are, you have to figure out what's being subtracted, and that always has to go behind the minus sign. Well, multiplication is up next, and it's forgiving like addition is. You can multiply numbers in any order, and you get the same answer. You might come across times, one of the old terms that you knew for multiplication, or multiply by. If somebody says twice, well, that of course means that you're just multiplying by 2, and the mathematical term for multiplication is product. Lastly, we have division. Division is special like subtraction is. You have to be very careful with it. You always have to figure out what you're dividing by, and that has to follow the division sign. So you might see divided by, but there is of course an historic term here meaning division. It's called quotient, and quotient is just like the difference up here in subtraction. These are the only two words used to indicate the basic math operations where you can assume that the numbers are given in correct left to right order. Again, for difference, whatever's to the left is in front of the minus sign, whatever's to the right in the problem is to the right of the minus sign. The same thing with quotient. When the word quotient is used, whatever number's to the left is to the left of the division sign, whatever number's to the right is to the right of the division sign. These are the only two terms, difference and quotient, where you can assume correct left to right order. All other cases for subtraction and division, you must be very careful. In subtraction, you must figure out what's being subtracted. That goes behind the minus sign. In division, you must figure out what you're dividing by. That goes behind the division sign. And of course, the nicest operations, addition and multiplication, really doesn't matter what order you add things or multiply things in, you get the same answer. Well, let's start looking at some of the problems dealing with all of this. Here's our first stop, the sum of 8 and n. Sum, of course, we know means to be able to add the numbers. And as we mentioned, addition is something that's very forgiving. You can add them in any order. So I'll just take them left to right as we are here. The sum of 8 and n can simply be 8 plus n. Okay, moving on. Next stop, we're going to talk about this problem, 11 increased by r. Increased by, the only way you increase anything is to add it. So we have initially 11, we're increasing it by r. The r is what we're adding to the 11 to make it larger. And so I could just take the numbers in left to right order here and write this simply as 11 plus r. Now, it would also be correct if I wrote r plus 11, because addition, it doesn't make any difference what order you add things in, but the 11 plus r more closely follows the word, so that's what we'll use in this case. Okay, next up, let's talk about some examples that indicate subtraction. Decrease by. How do you decrease something? Well, the only way you decrease something is you have to subtract something from it to make it smaller to decrease it. Well, what are we subtracting? We're subtracting the 27. So what that means is whatever's being subtracted, namely the 27, that has to go behind the minus sign. Here we go. The number that we started with goes out in front. There it is. So z minus 27 is the only correct way of being able to write down the expression for z decreased by 27. If you turn this around, it'd be entirely different. So remember again, any subtraction thing, with the exception of that special word difference, you have to figure out what's being subtracted to 27, and that has to go behind the minus sign. Okay, another way that we can indicate subtraction, right here, t less than 29. Okay, less than means we're subtracting. We have to make something smaller. Okay, well, what are we subtracting? The t is what we want to have to be less than 29, so we're subtracting the t here. And that means that the t then has to go behind the minus sign, okay? And what are we subtracting from it? T less than the 29? Well, 29 minus t is the correct way we have to put this one. So notice here, here's an example where the t, although it shows up first, has to go last behind the minus sign. Again, here's what's going on. Less than means we're subtracting. We want t less than 29, so t less means the t is being subtracted. That means the t must go behind the minus sign. The 29 then goes in front. Now, of course, we've mentioned to you this magic word for subtraction, difference. Okay, difference is the only way of indicating subtract where we assume that the numbers are given to us in correct left to right order. That means, among other things, if you ever use the word difference yourself in a problem, you have to make sure that you give the numbers in correct left to right order, because that's what everybody's going to assume. Now, why is difference special? Again, it's a historic thing. It's the way it's been in math, and it's just something that you have to be familiar with. So, difference means we're in correct left to right order. So, this one here, simply m minus 5. Again, difference indicates correct left to right order. Okay, next up, let's take a look at something that indicates multiplication. And remember, of course, product is the mathematical term to indicate that you're multiplying. And mathematics here, we have both addition and multiplication as being able to add or multiply in any order. So we don't have to worry about really what order we put this in. I'll just again take them left to right, and we could write this as n with the multiplication dot times 11, okay? Or I could turn around and write n and put 11 in the parens, but also because we can write these numbers in any order, I could also put the 11 in front and simply put the n after. And this is the way we often write things that are multiplied together. Any number next to a letter means multiplication. All three of these are the same and would give you exactly the same answer. The reason, of course, product means multiply, and you can multiply in any order. Okay, let's take a look at some of the dividing things. Here we go. V divided by 4. Well, not hard to tell that this means division. What are we dividing by? Well, the 4. So remember, division is just like the process we have with subtraction. You have to be careful. Whatever you're dividing by has to follow the division sign. Well, there's a division sign, so the 4 has to follow that. And the V then is what we started out with. So here it is, V divided by 4. Now, of course, one of the things we know about division problems is we can write them as fractions, and we'll do that more and more in the algebra as we go on. V divided by 4 can also be written as V over 4. This is V divided by 4. So both of these methods are telling us the same thing. Okay, the last one to take a look at, back visiting division once more. Here's that special word for division, quotient. And remember again, quotient is like difference. They're the only two words which you can assume correct left to right order. And so quotient means we're dividing. It's division. And here's the guy on the left, here's the guy on the right. So how would we interpret this? Well, simply the guy on the left, the x, divided by the guy on the right, 3. So x divided by 3, when we see quotient, we assume correct left to right order.